Hello everyone and welcome to Module 2 of Lesson 8. In the previous module, we covered the topic of define project activities. Today, we will discuss sequencing project activities, a critical aspect of project planning that ensures tasks are completed in the right order. We'll focus on precedence relationships, which define how activities relate to one another. There are four main types of precedence relationships: finish to start, start to start, finish to finish, and start to finish. Let's explore each of these in detail. The most common precedence relationship is finish to start. Definition: in an finish to start relationship, the successor activity cannot start until the predecessor activity finishes. Example: imagine you're painting a wall, predecessor activity. You cannot start hanging pictures, successor activity, until the paint has dried. Usage: this relationship is often used in construction projects, where one task must be completed before the next one can begin. The next type is start to start. Definition: in an start to start relationship, the successor activity cannot start until the predecessor activity starts. Example: if you are writing a report, predecessor activity, and need to simultaneously begin reviewing it, successor activity, as soon as the writing starts, both activities must start at the same time. Usage: start-to-start relationships are useful when activities need to be coordinated to run in parallel for better efficiency. Another type is finish-to-finish. Definition: in an finish-to-finish relationship, the successor activity cannot finish until the predecessor activity finishes. Example: if you are testing a software application, predecessor activity, you cannot complete the testing process until you have also completed documentation, successor activity, of the test results. Usage: finish-to-finish relationships ensure that dependent tasks are completed in tandem, which is crucial in ensuring project milestones are met concurrently. The final type is start-to-finish. Definition: in an start-to-finish relationship, the successor activity cannot finish until the predecessor activity starts. Example: in a manufacturing process, a shift handover, successor activity, cannot be completed until the next shift has started, predecessor activity. Usage: start-to-finish relationships are less common but are useful in situations where activities must be staggered to ensure a smooth transition or continuity. In conclusion, understanding precedence relationships, finish to start, start to start, finish to finish, and start to finish, is essential for sequencing project activities effectively. Each type of relationship has specific use cases and benefits, helping to ensure that tasks are performed in the correct order and dependencies are properly managed. By leveraging these relationships, project managers can create realistic schedules and enhance project coordination. In this section, we'll discuss the types of network diagrams used to visually represent these relationships. Specifically, we'll cover the precedence diagramming method, PDM, and the arrow diagramming method, ADM. Let's start with precedence diagramming method. The precedence diagramming method, PDM, is a network diagramming technique that uses nodes to represent activities. Nodes: in precedence diagramming method, each node represents a specific project activity. Visual representation: nodes are typically boxes or circles containing information about the activity, such as its name, duration, and start-finish dates. In precedence diagramming method, arrows are used to show dependencies between activities. Arrows: the arrows indicate the logical relationships and sequence between nodes. The direction of the arrow shows the flow of the project activities. Types of dependencies: precedence diagramming method can depict all four types of dependencies we discussed earlier: finish to start, FS, start to start, SS, finish to finish, FF, and start to finish, SF. Precedence diagramming method is widely used due to its flexibility and clarity. Usage: precedence diagramming method is commonly used in project management software like Microsoft Project. It is effective for planning and visualizing complex project schedules, making it easier to identify dependencies and potential scheduling issues. Benefits: the method allows for clear representation of dependencies and can accommodate all types of precedence relationships, making it versatile for various projects. Now, let's discuss the arrow diagramming method, ADM, also known as activity on arrow, AOA. Nodes: in arrow diagramming method, nodes represent the start and end points of activities, rather than the activities themselves. Milestones. These nodes often indicate milestones or key events in the project timeline. In arrow diagramming method, arrows are central to the diagram as they represent the activities. Arrows, the arrows, which connect nodes, represent the actual project activities, with the length of the arrow often indicating the duration of the activity. Single dependency type, arrow diagramming method primarily uses finish to start, FS, dependencies, which can limit its flexibility compared to precedence diagramming method. Arrow diagramming method is less flexible but can be useful in certain scenarios. Usage. Arrow diagramming method is particularly useful in simpler projects or when a straightforward representation of activities and dependencies is needed. It's often used in project planning tools like PERT charts. Benefits. Arrow diagramming method's simplicity can make it easier to understand and manage for smaller projects with clear, sequential activities. In conclusion, both the precedence diagramming method, PDM, and the arrow diagramming method, ADM, are valuable tools for sequencing project activities. Precedence diagramming method uses nodes and arrows to represent activities and their dependencies flexibly, accommodating various types of relationships. Arrow diagramming method, on the other hand, uses arrows to depict activities and nodes for milestones, typically employing finish-to-start dependencies. Understanding and choosing the right network diagram method can greatly enhance your project planning and execution. Now, we'll discuss the benefits of using network diagrams in project management. Network diagrams offer numerous advantages, including visual representation of project activities, identification of critical paths, determination of slack time, and identification of bottlenecks. Let's explore these benefits in detail. The first major benefit of network diagrams is their ability to provide a visual representation of project activities. Clarity. Network diagrams clearly illustrate the sequence of project activities and their interdependencies. This visual format helps project managers and team members quickly understand the project flow. Communication. They serve as an excellent communication tool, making it easier to explain the project plan to stakeholders, team members, and other interested parties. Example: imagine trying to describe a complex project schedule verbally. It's much easier to grasp when presented as a network diagram. Another crucial benefit is the ability to identify the critical path. Definition: the critical path is the longest sequence of activities that must be completed on time for the entire project to be finished on schedule. Importance: identifying the critical path helps project managers focus on the activities that directly impact the project completion date. Any delays in these activities will delay the entire project. Example: in a construction project, if laying the foundation, building the structure, and installing the roof are on the critical path, delays in any of these activities will push back the project completion date. Network diagrams also help in determining slack time, also known as float. Definition: slack time is the amount of time that an activity can be delayed without affecting the project's completion date or other activities. Usage: by identifying slack time, project managers can allocate resources more efficiently and prioritize tasks that are on the critical path. Example: if painting the interior has a slack time of 2 weeks, it means this task can be delayed by up to 2 weeks without impacting the overall project schedule. Lastly, network diagrams help identify potential bottlenecks in the project. Definition: bottlenecks are points in the project where the flow of activities is restricted or delayed, potentially causing delays in the entire project. Identification: by examining the network diagram, project managers can spot activities that have limited resources or dependencies that could cause delays. Example: in a software development project, if multiple tasks depend on the completion of a single task like code integration, this task becomes a bottleneck if it gets delayed. In conclusion, network diagrams are invaluable tools in project management, offering a clear visual representation of activities, identifying critical paths, determining slack time, and pinpointing potential bottlenecks. These benefits enable project managers to plan more effectively, allocate resources efficiently, and ensure timely project completion. In this section, we'll focus on the steps to determine the critical path, specifically calculating the earliest start time, EST, and the latest finish time, LFT, for activities. Understanding these steps will help you identify the sequence of activities that determine the project's duration. Let's get started. The first step in determining the critical path is calculating the earliest start time, EST, for each activity. Definition: earliest start time is the earliest possible time an activity can start without delay, assuming all preceding activities start as early as possible. Importance: calculating earliest start time helps project managers identify how soon each activity can begin, which is crucial for scheduling and resource planning. List all activities. Start by listing all project activities in a table or network diagram. Identify dependencies. Determine which activities depend on the completion of previous activities. Assign duration. Assign a duration to each activity. Calculate EST for the first activity. The EST for the first activity is 0 if it has no predecessors. Calculate EST for subsequent activities. For each subsequent activity, the EST is the maximum EST of its predecessors plus the duration of the predecessor activity. Example: if activity A, duration 3 days, precedes activity B, duration 2 days, and activity A starts on day 0, then the EST for activity A is 0, and the EST for activity B is 3, 0 plus 3. Let's visualize this with a simple example network diagram. Activity A. EST equals 0 days. Duration equals 3 days. Activity B. EST equals 3 days. Duration equals 2 days. Starts after activity A. Activity C. EST equals 3 days. Duration equals 4 days. Starts after activity A. Activity D. EST equals 7 days. Duration equals 1 day. Starts after activities B and C. The next step is calculating the latest finish time, LFT, for each activity. Definition: LFT is the latest time an activity can finish without delaying the project's completion date. Importance: calculating LFT helps identify the time flexibility for each activity and prevents project delays. To calculate the LFT, follow these steps. List all activities. Use the same list of activities as for EST. Identify successors. Determine which activities follow each activity. Calculate LFT for the last activity. The LFT for the final activity is equal to its EST plus its duration. Calculate LFT for preceding activities. For each preceding activity, the LFT is the minimum LFT of its successors minus the duration of the activity. Example: if activity D, duration 1 day, finishes on day 8, and activity D is the last activity, the LFT for activity D is 8. If activity C, duration 4 days, must finish before activity D starts, the LFT for activity C is 7, 8 to 1. Let's visualize this with the same network diagram example. Activity D. LFT equals 8 days. Activity B. LFT equals 7 days, 8 to 1. Activity C. LFT equals 7 days, 8 to 1. Activity A. LFT equals 3 days, 7 to 4. In conclusion, calculating the earliest start time, EST, and the latest finish time, LFT, are critical steps in determining the critical path. These calculations help identify the sequence of activities that directly impact the project's duration, ensuring efficient scheduling and resource allocation. By understanding and applying these methods, project managers can effectively manage timelines and prevent delays. Now, we'll focus specifically on the critical path itself, its definition, its impact on the project, and the concept of zero slack. Understanding these elements is essential for effective project management. The critical path is a fundamental concept in project management. Definition: the critical path is the longest sequence of activities in a project that must be completed on time for the entire project to be completed by its due date. Significance: it determines the shortest possible duration to complete the project. Any delay in the activities on the critical path will directly result in a delay of the project completion. To identify the critical path, project managers calculate the earliest and latest start and finish times for each activity. Example: in a simple project with activities A, B, C, and D, where A-B and A-C-D if the durations are A. 3 days, B. 2 days, C. 4 days, D. 1 day. The critical path is A-C-D, taking 3 plus 4 plus 1 is equal to 8 days, as it is the longest path. The critical path has significant implications for project planning and execution. Project scheduling: the critical path determines the project's timeline. By focusing on the critical path, project managers can ensure that the project stays on schedule. Resource allocation: resources can be prioritized for activities on the critical path to prevent delays. Risk management: identifying the critical path allows project managers to pinpoint which activities are crucial and develop strategies to mitigate potential delays. Let's consider a real-world scenario. Construction project: in building a house, tasks such as laying the foundation, constructing the frame, and installing the roof are on the critical path. Delays in any of these tasks will push back the completion date of the entire project. Non-critical activities: landscaping, which might be scheduled to occur later, has more flexibility and won't delay the overall project if it's postponed. Another important concept related to the critical path is zero slack. Definition: zero slack means there is no flexibility in the start or finish time of an activity. Any delay in these activities will directly impact the project's completion date. Critical path activities: activities on the critical path typically have zero slack because they directly affect the project timeline. Understanding zero slack is crucial for effective project management. Focus and attention: activities with zero slack require close monitoring and management to avoid delays. Resource prioritization: ensuring that activities with zero slack receive the necessary resources can prevent project delays. Example: if the installation of electrical wiring has zero slack, a delay here will delay all subsequent activities, such as wall finishing and painting. In this block, we'll discuss techniques to shorten the project duration, specifically focusing on crashing and fast tracking. Both methods have their advantages and drawbacks, and understanding these can help you make informed decisions to keep your projects on schedule. Let's begin with an overview of these techniques. Crashing is a technique used to shorten the project schedule by adding additional resources to critical path activities. Definition: crashing involves increasing resources, such as labor or equipment, to complete tasks more quickly. Objective: the goal is to reduce the overall project duration without changing the project scope. Let's explore the advantages of crashing. Speed: crashing can significantly reduce the project duration, especially when critical path activities are accelerated. Simplicity: the concept is straightforward: add more resources to get tasks done faster. Control: project managers can selectively crash certain activities that will have the most impact on the project timeline. However, crashing also has its drawbacks. Cost: increasing resources often leads to higher costs, which can strain the project budget. Diminishing returns: there's a limit to how much you can crash an activity. Beyond a certain point, adding more resources doesn't result in proportional time savings. Resource strain: adding more resources can lead to overcrowding and reduced efficiency if not managed properly. The next technique is fast tracking, which involves performing tasks in parallel that were originally planned to be done sequentially. Definition: fast tracking entails overlapping project phases or activities to reduce the overall project duration. Objective: the aim is to compress the schedule by performing tasks concurrently, thus saving time. Fast tracking has several benefits. Time efficiency: it can significantly shorten the project duration without additional costs. Flexibility: allows for overlapping tasks that don't have strict dependencies, enabling more efficient use of time. Immediate impact: fast tracking can quickly reduce the project timeline when done correctly. However, fast tracking also comes with risks. Risk of rework: overlapping tasks can lead to increased errors and rework if later phases depend on the successful completion of earlier ones. Increased complexity: managing parallel tasks adds complexity to the project schedule and requires careful coordination. Quality issues: fast tracking can compromise quality if tasks are rushed or if dependencies are not adequately managed. In conclusion, both crashing and fast tracking are effective techniques to shorten project duration, but they must be used judiciously. Crashing can quickly reduce time but often at a higher cost, while fast tracking can save time without additional expenses but increases the risk of errors and rework. Understanding the pros and cons of each method helps project managers make informed decisions to keep their projects on track. In our final block, we'll discuss key considerations when implementing these techniques. Specifically, we'll focus on performance impact, cost, and quality. Understanding these considerations is crucial for making balanced decisions that ensure project success. Let's get started. The first consideration is the impact on performance. Both crashing and fast tracking can significantly affect project performance. Definition: performance impact refers to how changes in the project schedule influence the overall efficiency and effectiveness of project execution. Key aspects: this includes team productivity, the effectiveness of task execution, and meeting project objectives within the revised timeline. Let's break down the potential impacts. Team productivity. Positive, accelerated timelines can motivate teams to work more efficiently. Negative, increased workload and pressure can lead to burnout and decreased productivity over time. Task execution. Positive, clear deadlines can streamline focus and efforts. Negative, rushed tasks may lead to errors and oversight, reducing the overall quality of work. Meeting objectives. Positive, shorter timelines can help meet project deadlines and client expectations more quickly. Negative, the risk of missing key milestones or overlooking important details increases with a compressed schedule. The second critical consideration is cost. Both techniques have financial implications that need careful evaluation. Definition: cost considerations involve assessing the financial impact of adding resources, crashing, or potential rework, fast tracking. Importance: balancing the project budget while aiming to reduce timelines is crucial for overall project success. Let's examine how these techniques affect costs. Crashing. Pros: can achieve faster completion times, potentially leading to earlier revenue generation or client satisfaction. Cons: increases direct costs due to additional resources, e.g., overtime pay, hiring more staff, renting extra equipment. Fast tracking. Pros: can compress the schedule without significant upfront costs. Cons: risk of rework and inefficiencies can lead to hidden costs, such as correcting errors and managing additional complexities. The third consideration is quality. Maintaining high standards while accelerating the project timeline can be challenging. Definition: quality considerations involve ensuring that the final deliverables meet the required standards and client expectations. Importance: quality is often compromised when activities are rushed or resources are overextended. Here's how these techniques impact quality. Crashing. Pros: with proper management, quality can be maintained by effectively utilizing additional resources. Cons: overloading teams can lead to mistakes and reduced attention to detail. Fast tracking. Pros: if managed carefully, concurrent activities can maintain quality by efficient use of time. Cons: overlapping tasks increase the risk of quality issues due to insufficient review time and potential task interferences. In conclusion, when considering techniques to shorten project duration, it's essential to balance performance impact, cost, and quality. Crashing can provide quick results but at a higher cost and potential strain on resources. Fast tracking offers time savings with less immediate cost but increases complexity and risk of rework. Carefully evaluating these factors ensures informed decisions that align with project goals and stakeholder expectations. In summary, sequencing project activities involves understanding precedence relationships, utilizing network diagrams, and determining the critical path to optimize project timelines. Techniques such as crashing and fast tracking can shorten project durations, but must be balanced with considerations of performance impact, cost, and quality. By effectively sequencing activities and managing these factors, project managers can ensure timely and successful project completion. Thank you for your time, and we will see you in Module 2 of the Lesson 8. Also, thank you for the support. Like and subscribe to the channel.